Hello everyone, welcome to discussion section for ECS 179, gameplay programming. Today we're going to talk about exercise 2. I wanted to save some time for Q&A for exercise 1. I'm sure some of you may still have some lingering questions. There were some questions on Discord that we answered, and there's actually some that came in since I last checked. Or at least someone answering a question. So good job participating on Discord. I know it's still a small fraction of people who have posted anything or conversed with that platform. If you haven't yet, and you need some clarification, it's a great place to go. All right. Get back to the meeting stage here. So once again, we're on the stage. Thank you for the 27 of you, 26 of you that are here. If you want to converse, feel free to raise your hand and chat or put a question into... I guess I'll be watching the class stage meeting text channel, so please post there. Where should we ask questions about the exercise? That's a great question. You should ask that in the exercise discussion channel inside of gameplay programming. It seems an apt place to go. All right, and I haven't sent this as a broad announcement yet, but via Canvas, but there is an announcement in the announcements channel in the gameplay programming category on this Discord server. That is a link to the GitHub Classroom for exercise 2. So feel free to check that out and get started while we are discussing. All right. We are streaming on Discord, so audio may be a problem again. So you may not get the audio of the project. We will be able to... You'll have audio in your own project. I kind of don't want to fix the problem because it's a lot easier to understand what I'm talking about and see the scripts without the game audio playing in the background. All right. So without further ado, let's get started. So here we have, I'm gonna make my face just a little bigger. We have going project loaded. We have exercise 2 camera controller. I was reviewing some other repositories. So here is the description. So you can go to the camera controller exercise repository. This is also linked in the README for the class right here. So the description. Your goal is to create several swappable camera control scripts for a top-down terraforming simulator. Here is the documentation covered in class. So basically, we are pulling from last lecture where we took a detailed look at Scroll Back, the Theory and Practice of Cameras and Side-Scrollers by Itay Kirin. Now, here is the description. Much like exercise 1 and like all the exercises will be, 70% of the points will be for your solution to the exercises and in the various stages, and 30% will be about your peer review. Now, peer review for exercise 1 will be released after today. So exercise 1 is due tonight at 11:59 p.m. We'll need some time to see who has turned in valid assignments and then assign peer reviewers. So you should get that hopefully Wednesday, and those will be due next Tuesday. So we will do the same thing, same peer review process for the camera controller exercise, and we'll be going over peer review process next class, probably on Thursday. Now, there are 5 stages. Stage 1 is worth 10 points. Stages 2, 3, 4, and 5 are worth 15 points each. So some things to cover. Each stage requires that you implement a type of camera controller. Your 5 camera controllers should inherit from the abstract camera controller class in the Obscura namespace. So Obscura is the name of the project in this case. As you can see in the project structure, we have the README, the get_ignore, Obscura, which if you look inside has the assets, packages, and settings. I may have to add a get_ignore to this. I'll have to see what the other turn-ins were like. I think this should be okay. So this denotes that this is a Unity project in Git. So Obscura is the name, is the folder you'll be loading as the project. All right. So each of your camera controller implementations should be added to the main camera object in the hierarchy. I have the key reference open to show at the end of class so you can know what the functionality should look like and how it should be structured. You should bind the player game object to the target serialized field via the editor for each one of your cameras. For the editor for each one of your camera. Maybe I'll clarify the language on that. So we'll talk about serialized fields today as well. How much of this do we want to go through? I think I'll go through the rest after we look at the project. So stage 1, position lock camera controller CS. So basically we want to implement the Terraria camera. So the camera controller should always be centered on the player game object. There are no additional fields to be serialized and usable in the inspector. Your controller should draw a 5x5 unit cross in the center of the screen when draw logic is true. So I want you to have the option of doing this draw logic to explain what's going on with your camera, to help debug it, to understand it. I want you to be able to turn off and on the draw logic at runtime. So the blue cross should, or the white cross should be able to be toggled off and on. Stage 2. Framing horizontal auto scroll. So in the grand tradition of shmups or shoot 'em up games, this camera controller implements a frame-bound auto scroller. The player should be able to move inside the box that is constantly moving on the positive x-axis. If the player is lagging behind and is touching the left edge of the box, the player should be pushed forward by that box. And it also is convention to be bound by the box on the in all directions as well. So basically the box keeps moving and the player has to be within that box at all times. Your camera controller should draw the frame border logic when draw logic is true, so it should draw the box around the frame border box. Now, the required serialized fields, these are the fields that will be exposed to in the inspector in Unity from your scripts. The first should be a vec2 top left, so that should be the top left of the border box. The vec2 should be the bottom right, which would be the bottom right area of the frame border box. And finally, the auto scroll speed. This should be the number of unities per second to scroll. Now, we'll be dealing in this open 2D plane world. So when you start this frame box, you can keep the default position of starting in the center of the world and scrolling right. That's all we're going to ask you to do is simply scroll right. Some people like to make this a little more capable to scroll in any direction and then start at the farthest edge so they have the most space to scroll. That is to you. We've had some folks in the past who have taken this and like scrolled it around the border of the playable space. So you'd start at the top left and then scroll to the right. Then as soon as you hit the corner, you'd scroll down. As soon as you hit the corner, you'd scroll left. Hit that bottom left corner, you'd scroll up and then just keep moving. That's up to you if you want to make this more capable. Often, if you do things like that, I'll give you show you've went above and beyond, and usually you get a participation code for something that advanced. So that is up to you. You can simply do the simple start from the center and scroll to the right indefinitely, which means you'll eventually go off the map. That's fine for this case as long as the logic of the camera holds true, aka the player is always within the frame and the frame is moving at a set speed across the terrain. You'll be fine. Stage 3, position lock and lerp smoothing. So I'm asking you to do the Super Meat Boy camera. So this camera controller behaves like the position lock camera controller from stage 1. The major difference is it does not immediately center on the player as the player moves. Instead, it lerps or physics smooths the camera's position to the player's position on update. If the player moves in an update, the lerp command should be refreshed. This means that you will constantly be restarting the lerp, and the camera will only truly catch up when the player is not moving. See the resources and hints section below, so it's at the bottom of the document, for the documentation on lerp. The duration of lerp should be lerp duration, serialized field that you're required to create. So I want you to also draw the same draw logic as stage 1 for this. And the only required serialized field will be the lerp duration, and that's how long the camera should take to catch up with the player when the player is holding still. Now, there are two ways to do this. You can use the linear interpolation function, which is a little awkward, which requires you to keep resetting the linear interpolation every frame until the player is not moving. And then the linear interpolation will progress to its end. Otherwise, every update, you'll just keep resetting the parameters because the player keeps moving, right? You'll want to keep lagging as long as the player is moving and only catch up fractionally with each frame. When the player is still, then the frames will accumulate, the lerp will finally end, and you'll be centered with the player. There are a few ways to do this. That is the progressive and progressively restarting lerp is one of them. Another is to pick a fraction, to expose another serialized variable, and to pick a fraction of the distance from the, or I guess to pick a fraction of the player's speed to catch up with the player. Kind of we talked about the speed up zone in Super Mario Brothers, which moved at a fraction of the speed when Mario was accelerating. You want to only follow the player while the player is moving at a fractional speed, and then pick a default speed to catch up to the player when the player is still. Right, so you have a couple options here. Stage 4, lerp smoothing, target focus. So this is the inversion of the Super Meat Boy camera. This is the look ahead camera. So this stage requires you to create a variant of the position lock lerp smoothing controller. The variation is that the controller camera leads the player in the direction of the player's input. The position of the camera should lerp to the player's position. Much like stage 3's controller, the lerp should be refreshed when the movement input is given, and the camera should only be settled on the player when the player has not moved for lerp duration. You should also draw a 5x5 draw logic here. The required fields are the lerp duration, so once again, the time it should take for the camera to catch the player when the player is still, and the lead speed should be the speed at which the camera moves towards the direction of the input. This should be faster than the player's movement speed, or else it would lag behind or stay the same. Would be centered on the player. Now, the whole point of this is to give the player some intelligent look ahead. So when they're moving, you want the camera to move ahead with them as well, right? So as you can see here with the Jazz Jackrabbit 2 example from Scrollback. When Jazz Jackrabbit is moving, you'll see that the center of the screen or the draw logic cross will be ahead of the player in the direction of movement. That's exactly what you want to pull off. Now, a lot of people will sometimes find jitter in their camera controllers, particularly this camera controller. And that is something we'll want to discuss. So basically there are two updates in Unity. There's the normal update, and then there is an update that happens before that. So one is there for you to update your positions and your logics, and the other one is for you to update the actual positions of characters, right? So we want to make sure that we have updated the positional movement for the player for the frame before we move the camera, because we need to know the leading direction of the camera of the player before we know how to position the camera for that frame. And if you allow both of these to work on both the player's update and the camera controller's update, it's undefined which one will happen first. So we want to force an ordering. So we will talk about that as well. And finally, the 4-way speed up push zone. This is the difficult one. So this is basically taking the Super Mario Brothers camera, but extending it in 4 directions. So if you take the push zone and rotate it by 90 degrees and put put one on each border, so you'd have the dark, the bold white line along the edges, and then a box of the thinner line in the middle. You basically have a speed up zone that is between those 2 boxes. So in between there, the camera doesn't move. In between them, the camera doesn't move. And on the speed up zone, I guess there are 2 variants of this. So if you're anywhere in the box, the camera will move fractionally towards it. And if you are within the speed up, the other second variant is if you're in the speed up zone, you'll move fractionally towards it. But if you were in the center of the 2 boxes, so you're not actually in between 2 of these lines, then the camera will not follow. Both of those are acceptable for this assignment. And a reference here for you is in gameplay programming. Oops, my bad. I hit edit instead of going to the actual website. Images. I have a visual guide. To the speed up zone. All right. So here, this is the variant when you don't move in the middle. And this is the variant when the entire center is a speed zone. So you get to pick. You can do either one of these. Both are valid. Both are valid interpretations of that camera controller. So there's a design decision to be made since we are extrapolating into a plane instead of one slice of just sort of like a more one-dimensional version of it. This is a 2-dimensional version of the problem. There is some open question, some design question about what do you do with that new space that you opened up in the middle. And these are the 2 solutions to that. And here's talk of some of the math. But let's go back to the description. All right, this camera controller should implement a 4-directional version of the speed up push zone as seen in Super Mario Brothers. The controller should move at the speed of the player, multiplied by the push ratio. It says ratio, should be ratio. I'm gonna just edit that real quick, maybe before some of you. Push ratio. There we go. There's 2. Oh my gosh. Okay. Hopefully that'll be enough. Push ratio. Okay. The controller should move at the speed of player multiplied by the push ratio required serialized field in the direction of the player movement when the player is 1, moving, and 2, not touching the outer push zone border box. So that's basically this case where Mario is coming from the left and is between these 2 lines, and the camera speeds up. The camera moves, but only at a fraction of Mario's speed until Mario hits the right side, and then Mario pushes the camera. So that's what this sentence here is referring to. When the player is touching one side of the push zone border box, the camera will move at the current movement speed in the direction of the touch side of the border box at the push ratio in the other direction. That's right. When the player is touching the middle of the push box but is moving to the upper right, the camera will move at player speed in the Y direction, but at push ratio in the X direction. So this is the case when you are moving up and diagonal like this way. Now what will happen is you will move at the X component direction. So you'll be moving at, let's say, if you're moving at 1, 1, right here. So you're moving exactly 45 degrees up to the right. you'll be moving that entire component, one component, to the right, but you'll be moving only at 1 times the push ratio up. So you'll move at full player direction, full player movement in both X and Y when you're exactly in the diagonal. Otherwise, you need to look at this as an X movement problem and a Y movement problem independently to know how to move the camera and get that camera speed up feel in 2 directions, in basically the 2 directional vectors that make up the plane. Oops, there we are. All right. If the player is touching 2 sides of the speed up push box, the camera will move at full speed in both X and Y directions. So as I just described, to get the current speed of the player, call get current speed and get movement direction from the player controller methods respectively. I provide those for you. Your controller should draw the push zone border box when draw logic is true. So it should draw 2, so it should draw an outer box and an inner box if you have the first variant. So this variant, you need to draw the outer box and the inner box. For this variant, you just draw the outer box. There we go. Keep messing with my tabs. All right, and so we need to know the push ratio, as described, top left and bottom right. So we need to know the borders of the box and then the push ratio. If you were doing the first variant, you'll have to decide like what is the distance between the 2 lines. And that's something you can expose as a parameter as well to tweak and tune. But it is not required since there are 2 versions of the camera controller that you could potentially use. All right, I know that was a lot. Let's take a look at the basic project, and then we'll take a look at the key. Any questions? Feel free to ask questions if you have them while we're chatting. All right, here we are in Unity. So the base scene here is the gameplay scene. So you can load the gameplay scene and the scene's assets, and what you'll see is something that looks like this. You'll see this big geometric terrain, right? Which is the terrain you'll be looking over. So when I hit play, we build, and you'll see that we have a capsule-based spaceship. Spaceship, and you can see there's a pretty distinct border box that we're flying around. You'll see that there's a trail behind the player. You'll notice that if you hit space for the jump entry, or the jump input command, that you'll move fast, the trail will become bigger and equal in free. Now, if you hit fire 1, you can raise the train. If you hit fire 2, you lower the train. So we're actually deforming and geometric down as we fly in. So this is now look at this. We'll make a really big train here. See, there's our big terrain spot. Really big. And you can see it jutting out. So that's the big mountainous urban spike that we put into the air, and it's so high into the air that it's immediately covered in clouds. So one thing to note is that the camera controller, the main camera here, we have our push box camera script. This is the script I give you by default. If you click the draw logic, you'll see that we're drawing notice it does indeed have our motion. This is, we're just pushing a box. We're not moving over the center of the box. We are moving around the box. All right, so that's the basic camera. We have a directional light, the PCG terrain object. So this is procedurally generated terrain using Perlin noise. We'll take a look at the code if we have time at the end. You won't have to deal with it for this project. But as always, I put some additional depth into each of the projects for you to explore at your leisure. This is one of those. We have the player object, which is a capsule mesh filter with a mesh renderer to render it, with a capsule collider for logical collision detection, which there is none of in this particular version. It's just there for potential future use. And we have our camera control script, which we'll take a look at, which has the speed at which the character moves, the boost factor. So when you hit jump and you get the speed boost, this is the factor of speed that you'll be moving at, so 4 times speed. We have the power, that is the this speed at which terrain raises and lowers with Fire 1 and Fire 2. We have the terrain generator script linked here, and we have the trail decay, and that's the how long it takes the trail to disappear. And we have a trail renderer, which is a special Unity object that helps us build things, that helps us build the trail. It's a little component that we can use, and you can see we've made its color, time, etc. So you can take a look at this and see how the trail renderer works. You don't have to modify it for this game, but it is there for you to look at. All right, and then we have a sound manager which handles our sound. We haven't went over the sound manager yet, but if you're curious on how the sound manager works or want to modify it yourself, we can talk about that during office hours. All right, so let's take a look at the assets. So we have in our assets folder, we have resources, scenes, and scripts. So we looked at scenes previously. This is our gameplay scene, and that is the scene you have to open to run the project. It's the only scene in the project, so you should work within it. We have resources. So we have our folder for audio. We have a set of materials, particularly the purple for the line. We have the audio mixer. So if you open the audio mixer, you'll get this tab where you can change the audio balance settings for all the game sounds. We have a new terrain asset and a terrain shader. Both of those are used in the production of the procedurally generated world. And in audio, we have 4 different audio files. We actually have 2 different music options for you to choose from if you want to change up the music. One's more like Pilot Wings style fusion jazz, and the other is a more sci-fi, like ambient space theme. All right, so those are our resources and our scripts. So we have a few scripts for the project, so I'm going to drag the slider all the way to the left so we can get a list so you can see the actual names here. We have the abstract camera controller. We have the player controller. We have the camera that I gave you, a default camera that you can use from. And this push box controller we'll look at in detail. It's the one that the camera was currently using. It's the one that is attached to the main camera right here. Sound clip and sound manager are for the audio system, and the terrain generator and terrain editor are for the procedurally generated terrain. So you will be dealing with will be a user of the abstract camera controller. So your camera controllers will inherit this abstract class. You'll be modifying or using the camera controller, and you'll be using the push box camera, or you'll be really using push box camera as an example or as a template to create your 5 camera controllers. All right, any questions about the basic layout of the project? We just went over everything in the project. It is the a lot of the so there was a lot of Unity specific tools and devices in Exercise 1. Exercise 2 is more stripped down to the programming and basic game objects and cameras and scripts. So this one you should be able to understand everything except for maybe the sound system and the procedural content generator from code all the way through what shows on the screen. There should be very little that's not transparent to you. Everything should be fairly open and clear. Whereas I imagine there were a lot of systems like the animation state machine, the sprite sheets, the sprite animations, defined animations that were a little more opaque to you. Maybe the parallax scrolling that was a little more opaque in Exercise 1. Exercise 2 should be more clear. All right. I don't see any questions now. I don't see any raised hands. Let me just take a look. Okay, there are no requests. So let's take a look at some of the code so you can see what's going on. So first, let's take a look at the player controller. Let me put it in the correct screen. All right, so here is the player controller. So first, we have something you may not have seen before. We have right here a meta tag. This is, I don't know if I'm getting the exact name for these in C#. It is a bit of information used by the compiler to add in or to augment classes in various ways. It uses a lot of reflection to be able to modify properties of a particular class or instance of a class, depending on how you use it. In this case, Unity adds a required component attribute tag, and it passes in the information of type of trail renderer. That means for this player controller to be added as a component to a game object, that game object has to have a trail renderer on it. Right, so we're calling this here this.trail renderer, since we need to access that trail renderer that we want to change its properties and make sure it works for us. So we need to make sure that one exists on the game object that this component, that this mono behavior player controller is also on. Otherwise, it'll break. So this is a way to specify a dependency. So public class player controller, it is a mono behavior. Now here we have a bunch of private variables: speed, boost factor, power, the terrain generator, and the trail decay. These are all values that you notice were in the inspector. So going back here, main camera, player controller script, speed, boost factor, power, generated terrain, trail decay. All of these are present in the inspector, but they're private. These are private and they're not on the inspector. So what's the deal here? Well, this is another specifier, serialized field, which tells Unity, hey, these values, these methods, these fields of this class are something that we can serialize or write their values out to disk. For Unity, that gives us a couple interesting improvements, gives us a couple interesting capabilities. First is that there can be a meta file that accompanies instances of this class, so that when you change the values in the inspector, those values will persist. So when you change values in the inspector, default values of these variables, it won't change the initialized values here in code. So when the player controller, when instances of this class are made, they will initially be these values, but very quickly Unity will check to see if there's a serialized version of those values like you've edited in the editor, and it will change those values of this class, of this instance of the class, to match those stored in the meta files, or aka how you changed them in the editor. Right? So, but these are default values. So that's one thing of serialized fields. Another thing about serialized field is that it tells Unity, hey, expose these private fields in the inspector, or expose this field into the inspector. So this allows us to change those values as you would public variables, but it also gives us the code safety of them being private instead of public or protected as well. Right, so serialized field is pretty important and is definitely one of those best practices that you should look for when you're peer reviewing. All right. We also have modified speed. So this is the calculated speed, basically used for boosting. We have the movement direction that we store around, and we have a reference to the trail renderer. Our awake function. So awake is a little different than startup or on enable. Awake also happens when the project goes from being minimized to maximized. Or when it wakes up for the first time. We have our transform.position. So when this first started, we placed the player in the middle of the generated terrain. So half of its width, half of its height. So trail, so this is the initial position of the player in the scene. We're getting a reference to the trail renderer, and we're making sure it's valid. So that's sort of the initialization portion of the player controller. Get current speed returns modified speed. Get movement direction returns movement direction. So these are convenient accessors for you to use in your camera scripts, that we give those as public versions of these private variables, the common pattern for encapsulation. And finally, we have our update function. So this is the major function of the camera controller. First, we're looking for input. We're getting the state of the controller or of the controls. So we get whether fire 1 is pressed, whether it's down, up, or currently held down. So whether it's this frame pressed down, or it has been held down before and is currently still pressed this frame, or whether it is up this frame. All those matter when you are dealing with various detailed movement mechanisms inside of a game. So basically, if fire 1 is pressed, we change the height of the terrain, either up or down. We'll play the beam sound if either fire 1 or fire 2 is pressed. So that's the noise you'll notice, like sort of like hissing beam noise when the terrain is being modified. And first we set the speed, modified speed to B speed, and then if the jump is pressed, we'll multiply the boost factor, and we'll multiply the trail width by the boost factor as well to make the trail larger. And then if the button is pressed, we want to start, if press starting this frame, we want to start the sonic boom sound effect of moving at boost. Notice we don't do this when button is pressed. We only do it when button is down. So we only want that one frame where you actually press the button to start the sonic boom sound. Now, we set the trail renderer. So if we're not boosting, we want to make sure that our trail renderer values are reset to the normal trail time, trail decay, and width multiplier. But we do in here every update, every frame, update this movement direction variable to be the axis inputs. So this also, you can use a thumbstick, right, and not move it all the way to the left or all the way to the right. So basically you have this, this circular value where the thumbstick can be at any point within that circle. So we want to make sure we have that 2-directional value be present in movement direction. If you're using WASD or arrow keys, These will be either zeros or ones in either direction. And we're making sure that we don't move in the z-axis. And then we are, instead of relying on the physics system and the rigid body to move our ship, we are directly translating the transform. We are handling physics ourselves. And the diegetic reason, or the reason within the fictional world that we're doing this, is that this is a very advanced alien spacecraft or future human spacecraft that can terraform. It has control over the physical world. So it can move precisely exactly how it wants and can basically remove itself from being subject to the laws of physics. So there's a diegetic reason for actually just moving it around as we want instead of dealing with the rigid body in the physics system. Okay, any questions on the player controller? Did all this make sense to you? Okay. No questions yet, so we'll move on to the abstract camera controller class. So this is pretty simple. So we used interfaces for the command controller example, for the command software design pattern. This is using object-oriented programming to our benefit. Basically, we want all of our cameras from all of your stages to have certain properties so they can all work in the scene. So we're in our obscure namespace. So basically, we have this abstract camera controller class that all of your cameras should inherit. So basically, you'll inherit this, but it also means that when you inherit this, and when you make your controller, you'll have these require lines that come from your inheritance. So that means to put your camera controller on top, or as a component on a game object, that game object will also have to have a camera in it. It also has to have a line renderer. You will inherit both a Boolean draw logic and a game object target field. But here we have our first abstract aspect of this abstract camera controller: public abstract void draw camera logic. So basically, these abstract methods in abstract classes prevent instances from being made of them, right? There's abstract here. There's no definition for draw camera logic for this function. So you can't really use this class directly. You have to inherit it, and you have to provide a definition for draw camera logic. This is basically saying, hey, when you inherit this abstract class, you need to provide an implementation of this function in your class for it to be usable. So in some senses, it kind of functions like an interface. Although unlike an interface, it can provide a partial implementation instead of an outline of implementation that you have to fill in all of, that you're wholly responsible for. And I gave just a brief overview of abstract classes. I'm assuming who've taken object-oriented programming or are familiar with that for sort of the prerequisites for the class, you've done this before. If you need to go over this, we can chat during office hours. All right. So let's finish this out. Let's take a look at the push box camera. So here is the push box camera that I give you. Notice right away, it inherits abstract camera controller. So we can use draw logic and target in our code without having to define it. It already exists. So here we're using target. We didn't have to put target in here. We can just use it. And draw logic we'll use here and down here without having to define it. The last thing we have here is the draw camera logic. So this is what we're talking about, the function that you have to implement. If you since it is an abstract, it's defined as abstract within the inherited abstract class. So here's where you use the override keyword. Public override void draw camera logic. Override is saying, hey, we're overriding, this implementation overrides the implementation that I have inherited. So you need to do the same when you're making your own abstract camera controller class. You will override the draw camera logic function and then write your own. All right, so back here from the top, we have awake. So we're getting a reference to our camera that we want to manage with a camera controller. And we're getting a reference to the line render component. So we're getting our sibling components that we need to make our camera controller function. Now, here's what I was talking about, late update. So this late updates will happen after all updates. So this is how you can say, hey, this is how you can have sort of like a different class or a different set of functions that will run after the normal set of updates. So all the updates will run in an undefined order. Then all of the late updates will run in an undefined order. So the reason that the camera controller is in late update is it wants to respond to all of the changes and motions and movements that happen during update. So you can see that like the updates as being the stimulation of the game world. And late updates are sort of the things that respond to that, like the position of the camera. So this will, if you find like there's jittering in your code, jittering in some of your camera controllers, a lot of the times it'll mean that the camera is, somehow randomly or undefined in an undefined order updating before your game objects update their positions. So it's very common for your camera controllers to be in late update instead of update. All right. So the basic things we have here, we are making a target position. So this is the position of the target, which we bind the player object inside of Unity. So taking a look at that quickly. Main camera, pushbox camera script. It is targeting the player. So you can target whatever game objects you want with a camera. So we leave this as an open capability. And we get the position of the camera. So this is the camera. That is a sibling component. Now here, basically what we're doing is we're seeing if the target position is greater. So if we're moving up past the top of the camera. Like camera position.y plus top left.y. So then we're updating the camera position to track it. So this is the basic algorithm of Pushbox. We're just looking to see if we are touching each border, or if we're going past the border. And if we are going past a border, we move the border to match. We move the camera so that the border is in sync with the player object. Pretty simple conditional logic. And after we do all the camera positions, so note that these are ifs and not if else. So that way, if we are in a diagonal corner, one of the diagonals, we can update both X and Y. And after we have accumulated all of those updates in camera position, we then, after checking all of the sides, change the position of the camera game object. Then we check to see if the draw logic Boolean field is true. And if it is true, we enable the line renderer and we call the draw camera logic function. If it is false, we make sure that the camera line renderer is disabled. Now here is the draw camera logic function. So notice first we make a variable z here. So the line, the draw logic is a physical thing in the world, much like any other game object. So what we have here is we want to know what level we should draw the bounding box at. Well, we want it to be drawn at the same height, or z value, so z is up in our world. We want the z value to be the same as the player. Is that true? Yeah, so we manage the z value. Now, the camera line renderer that we use to draw the game logic is sort of like Turtle Graphics, right? You're making a sequence of lines here. So here, notice that we are doing position count. We are not using world space. So these are relative to the origin or the camera 0, 0, 0. Right? So this is why when we calculate the Z, we are doing some calculations and not using the target directly. We need to know the offset from the target from the camera because we're using the camera's position as 0, 0, 0. So it's relative coordinates to the camera, not absolute coordinates to the game world. If you put use world space as true, it would be relative to the game world. Or it would be relative to the game world instead of the camera. So it is false. 0, 0, 0 is the camera's position, and we move from there. That makes the camera renderer, the line object, much easier to handle. So basically, we are starting drawing at the top left. Then we move to the bottom left. Then we move to the bottom right. Then we move to the top right. And then we draw the final line to the top left. Right, so we're basically drawing the box. So with the line renderer, all of the lines are connected. So that means when you're drawing the plus, you're going to have to figure out how do you draw a plus without having a diagonal. So, basically you draw crossed one, then you draw back again over that line to go to the center, then you draw up and down. So that's how you handle the plus without having weird diagonal artifacts on it from going from point to point. Now, your camera controller in stage 5 will be a little more interesting when you draw the line logic around it. Basically, most people, what they do is they put one diagonal in it, or they add a second line renderer, which can be a little more difficult to handle. So it'll be up to you to figure out that particular problem. All right, questions at this point. We've went over all the code that's relevant to you. You will be using a lot of vector math, a lot of X and Y positions, which is a really common gameplay programming task. If you want to talk about vector mathematics or how vectors work, happy to do that during office hours, where you can ask questions now or during class or on Discord. I'm happy to help you. I will load up the key while looking in the class meeting stage chat for questions. I see that there's some things happening in exercise discussion. I'm not tracking that particular channel at the moment. Okay. I believe this is the key. Yeah, let's take a look. Okay. So push box camera. So you should only have one camera controller enabled at a time. Loading this project. So you can see, same thing here. Box camera works. We'll disable it. Let's move to stage 1, the position lock camera. Draw logic is turned on. So notice that the camera controller has all of the camera controller scripts on it, and I can just select one to use. So now we're position locked. Now you can see that draw logic centered on. I'm not too picky about the size of it. The draw logic should just be indicative of the camera's action. You have that 5x5 coordinate grid that I state in the camera controller size and the soft camera. Just make it. All right. Looking at the auto frame scroller with the draw logic turned on. This is stage 2, what it should look like. Note that it's moving, and it's moving the player along with the box. The player can move all around the box, but it's still bounded in. Just like all the box. There's a few enemies coming from the left. stuck within the bounds of this auto. All right, let's look at stage 3, the position follow camera. This one has a little jitter, so there is some problem with the updating, and okay, so let's update first. On update, notice there's a little jitter, and then it eventually okay, so how you want to solve this typically is when you're close enough to the center. If you're within a small radius of the center, you count it as a center and just simply sync them up together. And that stops a lot of this action. So make sure you have numerical control to the center of the screen. Don't forget to tap this. Target focus camera. So the camera in its center should be leading the motion of the player. So notice I'm moving up. This one's jitter as well. Okay, I'll have to find a student flash drive. They got to put this more. We have an update problem, but you can see the basics here is the plus is leading in the direction of the player, and when you stop moving, don't mind the jitter. And finally, our 4-way speed up push zone camera with the draw logic turned on. Those were the controllers and how they work, minus the jitter, which you'll want to try and fix in yours. I'll find an example and maybe do an addendum to this to show you the key without jitter. Any questions? All right, well, I will take questions in exercise discussion. I will take questions in class. I will take questions during office hours. Okay, so that ends discussion for exercise 2. Do you have any questions on exercise 1? I'll take a quick peek at the exercise discussion channel. Okay, so this was some folks responding to the motivate command. Yeah, so when you have an error like this person is having with the game objects being null, this typically means you haven't threaded your game object through all the way, so that when we're trying to do collision detection, or when you're calling motivate is somehow getting an empty, a null reference. So it's kind of tracing your data structures to make sure there are instances everywhere you think there should be instances. Right back to the class meeting stage. I don't see any questions and people are starting to leave. So excellent. I'll take questions with other formats. I will stop recording shortly and post a video. Thank you for your time, and I will see you all at 1:40. Take care.